We're going to prove the sum of we're going to prove that the sum of three consecutive numbers is a multiple of 3. And that starts with us forming the expression. Okay? So we're going to prove that the sum of three consecutive numbers is a multiple of 3. We're going to form the expression. We have to prove this algebraically. So part of that is understanding the sequence we're going to work with, which is 2n, 2n plus 1, 2n plus 2. And we use that sequence because we want to make sure those terms are odd or even. And it's important to understand that 2n is an even number and 2n plus 1 is an odd number, and 2n plus 2 is another even number. They're all consecutive. Right, so we're going to add them together. So 2n plus 2n plus 1 plus 2n plus 2. We're going to add them. Sum needs to add. And then we're going to simplify by collecting like terms. So 2n plus 2n plus 2n is going to be 6n. And then we have the plus 1 and the plus 2, which is plus 3. And then the last part is to factorize. We're going to factorize. They've told us what we need to show. We show that the sum of those three consecutive numbers is a multiple of 3. So we need to factorize and have 3 outside of the brackets. So since 6 and 3 are both divisible by 3, we have 2n plus 1 on the inside, because if we expand the brackets we end up with 6n plus 3. And the last part is just to write the statement, and it's going to be pretty much the same every time, but if n is any integer, then 2n plus 1 will also be any integer. But if we multiply any integer by 3, then the result will be a multiple of 3. Okay, so that's all we need to write, but we've shown it, and then you just need to write that statement every time you see a question like this, right?